In today's video, we're going to discuss how to interpret graphs. A graph tells a mathematical story about a certain situation. Look at the following graphs and answer the questions. Question number 1. This graph shows someone taking a walk in the neighborhood. Describe what it shows by labeling each part. Okay. So if I look at my graph, I notice across the x-axis I have time, and up and down the y-axis I have the distance this person is from home. Okay. So this one right here, notice that I'm increasing my distance from home relatively quickly. Okay, so right here what's happening is I'm increasing my distance from home, so I'm going to be walking quickly. Okay, here I'm not increasing my distance. My distance is staying the same, yet time is going on. So that means this person is standing still. Okay. Here and here, again, I'm walking quickly, and I'm walking quickly here, but this time I'm going away from home, and this time I am walking towards home. So again, I'm walking quickly. And then here, again, I am standing still, right? My distance is not increasing or decreasing, it's just standing still, and then I finally finish my walk home. Alright, example number 2. A pelican flies above the water searching for fish. Tell what each section of the graph below could represent. Okay, so here's my pelican, right? My x-axis is time, and my y-axis is altitude. So I'm starting at time 0. Pelican is on the ground. He has an altitude of 0. And this is kind of like where the pelican is taking off. He's starting and he's ascending. He's going up in search of fish. So here, the pelican takes off. So he's starting his search. Okay, right here, this is like your cruising altitude. Time is going on, but the pelican's not really going up or down. He's just kind of cruising, looking for fish. So here, the pelican looks for fish. And then here, notice that my altitude is quickly decreasing, and again, we have an altitude of 0 at the end, meaning the pelican is back on the ground. And I would say this is probably where the pelican dives because he sees a fish. Alright, example number 3. Which graph could show a car sitting at a stoplight? So notice I have graph 1 and graph 2. If I'm sitting at a stoplight, my car is stopped. So my distance is neither increasing or decreasing, which lends us to assume that this would be graph 1. Because when you're stopped at a stoplight, distance doesn't change. So when you stop at a red light, distance doesn't change. Alright, example number 1 on the other side. We're looking at some interpreting graphs questions continued. Question 1. The graph shows a trip from home to school and back. The trip involves walking and getting a ride from a neighbor. Label each section of the graph. Okay, so here is my distance from home along the y and time along the x. So notice, okay, here my distance is increasing. I would say this is probably where this person is walking to school. Right? It says the trip involves walking and getting a ride. Here, I would say they are waiting for the ride. So they're waiting for the ride to come pick them up. Looks like here and here, they're riding. This one's riding to school. Since my distance is increasing, so my distance from home is increasing, therefore you're riding to school. This is during the day, so this would be while you are at school. Your distance from home doesn't really change too much while you're at school. Alright, now we're getting closer to home, so I would say this is riding home. This would be your drop-off, right? Waiting for ride or your drop-off while you're getting out of the car. Your distance isn't changing, you're being dropped off. And then here, this is where you're walking home. Until finally you get at the end and you've walked all the way. All right, number 2, sketch a graph of the distance from a child's feet to the ground as the child jumps rope. Label each section. So again, across the bottom, usually you're going to see time here. Okay, and then the distance to the ground would be your x-axis, or your y-axis, sorry. Distance to the ground. Again, that's your y-axis. Time is on your x-axis. And if you think about jumping rope, right, a child's feet come up as he jumps up or she jumps up, and then they come back down and they touch the ground as they land. So that would be one jump. Alternately, you might think that a child jumping rope, if you think about a longer time, might look something like this, where you go up and then you hit the ground, and then you go up and then you hit the ground, and you go up and you hit the ground. So it just kind of depends on your perspective. So you could either graph, this is one jump, this one would be multiple jumps. Our problem wasn't specific, so either one of those would have been an acceptable graph. Alright, last one, number 3. Suppose you pour water into each of the containers below at a steady rate. Match each container with a graph that shows the change in height of the liquid in the container over time. Explain your choices. Alright, so if I look at these 3 containers, and we're going to try and match them with a graph. Now, I would say that A probably matches with graph 3. If you look at this cylinder, or this mug is a cylinder shape. So as long as you're pouring in constantly, it ought to fill up at a constant rate. The bottom is the same size as the top. So A matches with 3. And the mug has a constant diameter. It's a cylinder. So if I'm thinking about this mug, it's the same on the top as it is on the bottom. It's the same size. Okay, so that one, notice here, I'm very steadily going up. It's not changing. It's not starting quick and then slowing down. It's very steady, consistent. Alright, if I look at B, look what I notice about B. My bottom diameter is much smaller than the top diameter. So as I'm pouring in the water, it's going to raise quickly at first, and then since this has more area to spread out over, it's going to start to slow down, or the height is going to start to go a little bit, it's going to increase a little bit slower. So B is going to match with A. So I'm filling up quickly, and then I'm starting to slow down. I'm still filling up, but it's happening at a slower rate. So the bottom is a smaller diameter than the top. And that means that graph 2 has got to match with C. And if I look at this, it kind of makes sense. The diameter at the bottom of this container is similar to the diameter at the top, so bottom is similar to the top. And then in the middle I have a larger diameter, so notice I kind of slow down in the middle. Okay. So the top and bottom diameters are the same. The middle diameter is larger.